Right, a bit of core further maths, method of differences here with a fraction with 3 factors on the bottom. So it's going to be good. I'm going to, first part says to do it, put that into partial fractions. I'm going to do it using the cover-up rule. Too much of it these days. So I'll write that fraction as a over the first factor, 2n minus 1, b over the second, and c over the third one. So here's how the cover-up rule works. We look at the first fraction. So I'm looking for find out what the a is. Now I make the bottom line 0 by making n equal to a half, and I sub that into the fraction I started with. So I put it into there, which means the two ends are all going to be 1, but I cover up the one that's 0. So that 2 ends 1, that 2 ends 1. So I actually got 1 over 2 times 4, that's 1 over 8. And then b, do the same thing again, but I need to make n equal to a half, minus a half now to make the bottom line 0. So I need to cover up that 2n plus 1 factor, so I'll get rid of that. And I'll put minus a half in, so the 2n will be minus 1, and minus 1 minus 1, and minus 1 plus 3. So I'll have minus 2 and plus 2 on the bottom. That'll give me minus a quarter. Get the c. Well, to make the bottom line 0, I need to make the n minus 3 over 2. And I'll cover up the last factor this time, the 2n plus 3. So the 2n is minus 3, so minus 3 minus 1 and minus 3 plus 1. Both negative, minus 4, minus 2, that gives me 1 over 8. So my partial fractions sort of look like that. Not a fan of partial fractions, they've got fractions in them, but what I'm going to do is multiply both sides by 8. So instead of having 1 there, I'll put an 8 there, and so I'll have 1, 2, and 1. So I'm going to be working out 8 lots of what I want in the end. So my partial fractions look like that. So with r's in, because I'm going to use r's now, not n's. And I'm summing it to the first n terms of both sides. And really what I'm going to do, I'm going to work out what it is, but I'm going to be working out 8 lots of it, so I'll end up dividing by 8 at the end. So on the right hand side, if I put r is equal to 1 in, I'll just have 1 over 1 plus 2 over 3 plus 1 over 5. When I stick r is equal to 2 on the right hand side, I'll have 1 over 3, 2 over 5 plus 1 over 7. Put r is equal to 3 in, 1 over 5 minus 2 over 7 plus 1 over 9. First 3 terms will do me. If I go right to the end, put the n in, I'll have 1 over 2n minus 1 minus 2 over 2n plus 1 plus 1 over 2n plus 3. Putting n equals minus 1 in. Well, I can actually do this just by taking 2 off the bottom, so I'm taking 2 away from the denominators. So I've got 2n minus 1, so I've got 2n minus 3. This one's 2 less than that one, this is 2 less than that one. And then I'll take 2 away again, I'll get those denominators. And I'm going to put some dots in at both ends, because I saw this mark scheme. It wasn't an Edexcel Pearson mark scheme. It was some other exam board, OCR. It said if dots missing, then some indication of existence of immediate independence must be seen. I don't really want to voice my opinions about this matter, but no, we don't need that in our lives, really. If you do OCR, avoid with your teacher. That's my advice. So here we go. So we're going to do some cancelling. We've got a fifth there, minus 2 fifths, plus a fifth, and they'll all cancel out. The sevenths will as well. So they're all cancelling out sort of diagonally because they've got the same denominator, and I've got 2 1s and a minus 2. So they'll all cancel out as well. Same with the other end. I'll get rid of those. They'll all cancel. So will those. And then what I'm left with at the top end, I've just got 1 over 1, minus 2 over 3, and 1 over 3. And at the bottom end, I've got those 3 terms. So So that's really what what my total is when I've done the cancelling out. Um, so the 8 lots of that, the sum that I want, is equal to that. I've got 1 over 1 minus 2 over 3 plus a third, and then those other fractions. So what I want is going to be an eighth of that. But the 1 over 1 minus 2 over 3 plus a third is just 2/3. Really, I've got 4/3 minus 2/3. And then I've got 2n plus 1 and minus 2 over 2n plus 1. So that's minus 1 over 2n plus 1. And then I've got the 1 over 2n plus 3. And I'm going to put that into one fraction. So I need a common denominator, of course. 3, 2n plus 1, 2n plus 3. First term's going to look like that. By both those brackets. The second one I just need to multiply by the 3 and the 2n plus 3, and the other one I'm going to need to multiply the top and bottom by 3, 2n plus 1. But yeah, if I multiply those out, I'll have 8n squared plus 16n plus 6 when I multiply it out and double it, minus 6n minus 9 plus 6n plus 3. Do a bit of cancelling. The minus 6n's will go. 6n plus 6n. I've also got plus 6 minus 9 plus 3. That will go as well. So I'm just left with 8n squared plus 16n on the top. I can divide the top by the 8 on the bottom of that fraction. So I've got n squared plus 2n, and then the bottom line is 3, 2n plus 1, 2n plus 3.